Good day, everyone. Today, we'll be talking about Hamilton's method. So before we will start, let me introduce Hamilton's method. So Hamilton's method is named after Alexander Hamilton, 1755 to 1804, the first U.S. Secretary of the Treasury and a founding father. In 1792, he proposed a way to distribute seats in the House of Representatives based on state populations. This approach, also called the method of largest remainders, was one of the first systematic methods of apportionment. Though later replaced, it remains an important foundation in studying fair division and proportional representation.
Hamilton's method is used to divide seats or resources fairly among groups. It assigns each group a number of seats based on their share of the total population. Any leftover seats are given to the group with the largest decimal remainders. This makes the distribution more accurate and fair. In short, Hamilton's method fairly divides seat/resources among groups based on population share. Leftover seats go to the groups with the largest decimal remainders, ensuring accuracy and fairness.
So first, let's define apportionment. Apportionment is the process of distributing seats such as in a legislature among different groups based on population. In simple words, it's about making sure every group gets representation according to how many people they have. For example, a bigger state with more people should receive more seats compared to a smaller state. Next, we have the standard divisor and quota. The standard divisor is found by dividing the total population by the total number of seats. This tells us how many people are represented by one seat. The quota is the exact or decimal number of seats that a group should get. It's calculated by dividing the group's population by the standard divisor. After dividing the quota, we move to surplus seats, lower quota, upper quota, and initial allocation. The lower quota is the whole number part of the quota or simply rounding the quota down. Upper quota is the next whole number above the quota or rounding it up. Initial allocation means each group is first assigned their lower quota. Sometimes after giving everyone their lower quotas, not all seats are distributed yet. These extra seats are called surplus seats. That's when the next step comes in. Now let's talk about the largest remainder in the final allocation. The largest remainder of the decimal part is the quota, which is used to determine how the surplus seats are assigned. To distribute the surplus seats, we look at the largest remainder. The groups with the biggest decimal parts receive the remaining seats one by one until all seats are assigned. The final allocation, the process of assigning surplus seats to groups with the largest remainders until all seats are distributed. This ensures that every seat is given fairly and proportionally. In summary, Hamilton's apportionment method is a fair way to distribute seats based on population. We use the standard divisor to get each group's quota, then assign seats lower to the lower quota as the initial allocation. Any surplus seats are given based on the largest remainder, leading to the final allocation where every group is represented fairly.
So today we're going to talk about the method of apportionment, basically how we divide seats fairly among groups based on their population. Here are the steps and procedure. First, find the standard divisor. So first, we divide the total population by the total number of seats available. This gives us the populations per set, or how many people each set should ideally represent. And second, calculate the standard quotas. And next, we take each group's population and divide it by the standard divisor. The result in their quota, how many seats each group should get. And third, assign the lower quotas. Now, since seats can be in decimals, we give each group the whole number part of its quota. For example, if a group's quota is 7.6, they get 7 seats first. And fourth, distribute the remaining seats. After giving everyone their lowest quotas, we'll usually have a few seats left unassigned. To be fair, we look at the decimal remainders. The part the part after the decimal point. The groups with the largest remainders get the extra seats, one by one until all seats are distributed.
Here is an example sample problems. 3 states must share 10 seats in the Congress. Their populations are State A, 4,200, State B, 3,100, and State C, 2,700. Use Hamilton's method to allocate them. The totaling of the 3 states is 9,800 populations.
Solutions. Now let's proceed to the solutions. So we have 4 steps. Number 1 is standard divisor, number 2 is standard quota, number 3 is lower quotas, and number 4 is remainders. So number 1 or the step 1, standard divisor. So to get the standard divisor, we need the total population divided by total seats. So here we have an examples. So 10,000 divided by 10 equals to 1,000. So 1,000 is equivalent to our standard quota. So step 2, we have A, B, and C. So A is 4,200 divided by 1,000 is equals to 4.2. And to B, 3,100 divided by 1,000 is equals to 3.1. And C, 2,700 divided by 1,000 is equals to 2.7. And for the step 3, we have here lower quotas. When A is 4, B is 3, C is 2, and you need to total this to get the remaining seats. So we have total 9 seats. So we have a 1 seat. Since our total seats from the problem is 10. So now, atong siyang i-minus mo nang nahimong 1 na lang ang seats ang nabili. And then for the step 4, we will be finding the largest remainder. So from the standard quota, we will go back to standard quota. So muna yung nakita na to 4.2, 3.1, and 2.7. So the points there, that is our remainders. So ato ibutang A 0.2, B 0.1, and C is 0.7. So the largest remainder is 0.7, which is equivalent to 1 seats. That is our solutions. So to conclude the answer or the interpretation, so we have the final apportionment is statement A, we have 4 seats, statement B, we have 3 seats, and statement C, we have 3 seats. Mag-wonder ka nga nung nahimo siya 3 seats nga 2.7. So 2.7, we round it off, that's why it become 3 seats.
Hamilton methods prove that mathematics can be used to create fairness in real-life decision-making, such as dividing government seats or resources by following clear steps, finding quotes, assigning whole numbers, and serving reminders. It ensures that representation is based on population and not on bias. Although later methods were developed to address some of its limitations, Hamilton's method remains one of the clearest and most practical ways to understand apportionment. It teaches the value of fairness, equality, and systematic problem solving, making it not only useful.
References: Balinchiki and Young, 2001. Fair Representation: Meeting the Ideal of One Man and One Vote. This book talks about how to divide things fairly, like seats in government, so that every person's vote counts fairly. Equally. Larson, Hostler, and Edwards, 2001. Elementary Linear Algebra. This is math textbook that teaches basic algebra concept, including how to work with numbers and equations. lecture notes, and mathematics of voting and apportionment. These are likely classroom materials or handout that explain how math is used in voting system. They show how to divide seats fairly among groups based on population using methods like Hamilton's.